Today we are going to solve the problem 2.10 of Griffith third edition Introduction to Quantum Mechanics. This problem consists of three parts. We will do one by one. First, construct ψ₂ of x, that is second excited state. Uh, Using harmonic, this is for harmonic oscillator. So we know the for harmonic oscillator, annihilation operator is equal to x over square root of 2 h cross over m omega. Similarly, plus ip over square root of 2 h cross m omega. I have explained in a lengthy lecture about this annihilation and creation operator. In creation operator, here the second part will become minus. Here it is plus, here it is minus. Both terms are dimensionless quantity. That is square root of h cross m omega is having the dimension of length, and h cross m omega having the dimension of momentum. So now you take, in order to find ψ₂, second excited state, then you need a creation operator. That is, you have to increase the step by 1. So the A dagger is you take 1 over square root 2. That also I have explained. This is for mathematical reason I am introducing 2. So 1 over square root of 2, then this will become m omega will become into the numerator m omega over h cross x, and this is here, this is minus because we are considering creation operator, minus I p over square root of h cross m omega. Now you label this as z. Uh, then this factor you replace p by its operator. P momentum operator is minus I h cross t by tx. Now this minus minus will become plus, and I squared will become minus. So that minus I have introduced here. Now this h cross you bring out. H cross can be written as a square root of h cross into square root of h cross. So one h cross will cancel this square root of h cross. So this will become minus square root of h cross over m omega t by tx. Now this also here x I am going to bring as z. I am changing the variable. So what is z from here we have taken as a square root of m omega over h cross multiplied by x. Then what is t by tx? Now we want this one, t by tx. So this can be written as dz over tx multiplied by t by tz. So now this is equivalent to t by tx. Now you differentiate this tz with respect to x. So the tx x will be 1. Then this will become square root of m omega over h cross, and then after that I am multiplying by this t by tz. Now I am replacing t by tx as m omega over h cross t by tz. So here you can see this m omega, square root of m omega will get cancelled with the square root of m omega, and h cross will get cancelled with this h cross. So ultimately I will get the annihilation operator A dagger is equal to 1 over square root 2 z minus t over tz. Like that, for annihilation operator, this minus will become plus. So we have reduced this it in a very simple form. That is the beauty of this reduction. So we will move further. Now we got this expression, that is annihilation, sorry, creation operator is equal to 1 over square root of 2 z minus t over tz. And we know that normalization constant for ground state energy is ground state wave function is m omega over pi h cross whole power 1 over 4. With this, we are going to now we are going to keep as a. Finally, we will introduce this one. So the wave function for ground state energy of the harmonic oscillator is psi naught is equal to a e power minus m omega over 2 h cross x squared, which can be written as I'm going to keep m omega over h cross multiplied by this x squared as z squared. So naturally this will become a multiplied by e power minus z squared. There is 2 here. So minus z squared over 2. Now uh, let us here is an operator act on psi naught so that it will become psi 1. So a dagger psi naught. This wave function is a, and this operator a dagger is this one, and the wave function psi naught is a multiplied by this exponential term. So if you differentiate this exponential term, what you will get? You will get minus z squared, sorry, not z squared, 2z squared over 2. So 2 will get cancelled. This will become minus z. So minus of minus will become plus. So z plus z, then this exponential term. This will be 2 times z. So 2 over square root of 2. 2 can be written as square root of 2 into square root of 2. Here you have square root of 2. 1 square root of 2 will get cancelled. So you will get this a, then square root of 2, then z e power minus c squared over 2. So now when a dagger act on psi naught, it will produce the psi 1. So psi 1 is equal to a square root of 2 z e power minus c squared over 2. Now we have found psi 1. That is psi 1 is equal to a multiplied by square root of 2 z e power minus z squared over 2. Just now we have seen. Let a dagger act on psi 1. The a dagger I have shown here is using yellow color font. So now here you can see square root 2 will get cancelled with the square root 2. So this term will become that is if a dagger act on psi 1, it will become psi 2, which is equal to a multiplied by z minus t over tz. So now you bring c inside. So 1z multiply, this is multiplicative factor. So if you multiply by z then exponential term, this will become c squared with that exponential term. Anyway, I am going to take it as common. Then next, you differentiate with respect to z first term. You differentiate z with respect to z. Then it will be 1. Already there is negative sign, so that will become minus 1. And the exponential term, as usual, we have taken out. Then what about you keep z as it is and differentiate this exponential term? If you differentiate this exponential term, as I said, you will get uh, already z is there. If you differentiate this exponential term, you will get to minus z and this exponential term. Simply, I will write exponential term. So z into c, you will get c squared. Already the one minus is square, so this will become plus z squared and this exponential term. So now z squared plus c squared is equal to 2z squared minus 1. So here you have a also multiplied by this exponential term. And now what is psi 2? Psi 2 is equal to a 2c squared minus 1 e power minus c squared over 2. So now you replace all the parameters. That is psi 2 is equal to a I have already shown, is m omega over pi h cross 1 over 4, and c is equal to m omega over h cross. Already there is 2. M over h cross x squared, c squared is equal. Then this is minus 1, and this is z squared is m omega over h cross x squared, and this 2 comes here. This is the wave function for second excited state. Now, section C is sketch ψ₀, ψ₁, and ψ₂. Ψ₀, we have seen a into e power minus c squared over 2. Ψ₁, a multiplied by square root 2 z e power minus c squared over 2. And ψ₂, we just now we have seen a multiplied by 2 z squared minus 1 e power minus z squared over 2. Here you can see ψ₀ is even function, and ψ₁, see, this is add function, and ψ₂ also even function. So keep it in your mind. We will do the we will do we are going to use this in future. Just now we are going to use this fact and find the orthogonality property. So now first you draw the diagram psi naught. Naturally, this is a simple Gaussian, and psi₁, it will look like this, because this is the z is there. So for positive you will get positive, for negative you will get the negative sign. Similarly, this will look like this. So this is psi₂, psi₁, psi₀. Now we will move for section. Now section C is to check the orthogonality of psi₀, psi₁, psi₂. Just now we have seen psi₀ and psi₂ are even function. Are even. These two wave functions are even, and psi₁ is add. So if you multiply psi₁ and psi₂, you will get add integral. Naturally, it will be zero within the symmetrical limit. So you need not check psi₁ with psi₂, or psi₁ with psi₀, because this is add. So add integral between the symmetrical limit will be 0. Now you take psi₀ and psi₂. So psi₂ star psi₀ dz is equal to a squared. This is psi₂. Psi₂. 2z squared minus 1 multiplied by this exponential term. And what about psi₀? Psi₀ is this one. E power minus z squared over 2. Then you can write this. That is, you will get a squared over 2 z squared. You can separate it to 2 integral. See, first, before that, I like to explain this. If you multiply these two exponential term, you will get e power minus z squared, simply z squared. Because here over 2, here also over c squared over 2, c squared over 2. Then the remaining thing, you will get 2 integral. So one is a squared, and you take the first term 2. 2 is a constant. I am taking outside of it at the integral. Then z squared and this exponential term. And minus 1 a squared. Uh, this e power minus z squared. What is e power minus z squared? Using Gaussian integral, this is square root of pi. So that I have written. What is this value? This value is equal to half square root of pi. So this is using Gaussian integral. This is half square root of pi. So this will I can rewrite this. I already there is 2 here and 1 over 2 square root of pi, this integral. This one will be simply square root of pi. So here 2 will get cancelled. So square root of pi minus square root of pi is 0. So we have proved. So wave function is orthogonal with each other. Thank you very much for watching my video and supporting me continuously. Thank you very much.